Hello everyone. My name is Greg McCarron. I'm a vice president with SCS Engineers. Happy to be here with you today to talk about composting. There's certainly lots of activity and work within the compost industry these days. A lot of that's dictated by regulatory policy in various states and municipalities having organic diversion laws. But also there's a lot of activity, just folks that are looking to do the right thing and through their environmental activities, see composting as a good thing to do. And so, here at SCS, we're often having conversations with clients and regulators and others. And usually the questions come up such as technology, what technology should I use to begin compost or to continue to compost as my feedstocks grow. There's a question about land, so how much land do I need to host a compost facility and project? Or similarly, is my existing site sufficient? Is it big enough to host a compost project? Under the regulatory icon here that I'm showing, things come up, certainly there's regulatory policy, as I just mentioned. So, do I, within a particular state, have to divert organics from a landfill or waste energy facility? But other regulatory issues apply as well. And so a question is, what regulations are going to apply to my compost operation? So key among those are odor concerns as well as emission concerns. In California, there's some air districts that require testing of VOC emissions as well as ammonia emissions. And in New York State, something that's emerging, it's very hot topic, emergent issue is greenhouse gas emissions. And there's some activity going on within New York State that suggests that folks have to compost more because that's going to result in greenhouse gas reductions versus the current scenario of mostly landfilling waste. And then finally, under water regulatory issues is water management. So, what do I need to do in terms of water management? And then ultimately, of course, everything comes back to cost. The question is, how much will it cost? And, does my project make financial sense? So those are questions that are always being asked, both of us and then internally, our clients, both public and private, are asking these kinds of questions. So we're going to talk about two case studies today. And the first one, the two issues on the right-hand side are kind of more dominant, more heavily weighted. So, those were the key issues that we had to address. And then in the second case study, the issues on the left, technology and cost were more the bigger issues that we had to address. Delving into the technology considerations a little bit more, technology is a key item in composting, but one distinct advantage that composting has versus other organic processing operations, as well as really other solid waste operations, is that it can work at a wide range of scales, and both from a low technology perspective as well as a high technology perspective. So it's the compost process, really that biological process is very robust. And in any kind of system, we're trying to get as close to the ideal conditions for the bacteria and the fungi to do their thing. But if we're not quite there, the process still works. And so there are a lot of different technology options that are available, and they all work. But depending on which one you select, certainly we're trying to get it to an optimal state. So, as we go through the slides here, we'll touch on some of these technology differences, and we'll kind of compare and contrast the two case studies that we'll present. So first, working left to right here. So the aeration mode really references, do we have a static system or do we have some kind of forced air system? And that forced air system might be positive air, it might be negative air. In containment level, here we're talking about, are piles out in the open, or are they covered, whether that's with a bio cover or with a synthetic membrane of some kind. And then also there's enclosed systems, both in building systems as well as things like composting drums. Next is degree of agitation. So, again, are we static? Are we just sitting there without any kind of agitation, or do we have agitation, such as with a windrow turner or other turning mechanism? And then finally, material movement. So this is both within the compost process itself as well as the overall system. Are we working in a batch mode or a continuous mode? One way to think about this, and we'll show this later, is are we moving materials by conveyor or by trucks? So again, these are just kind of setting up some of the key focus points that we're going to touch on today. But with that, we'll move to our first case study, which is in California, and I'll turn this over now to my colleague, Vidhya.
Thank you, Greg, and thank you to everyone who could join us today. I am recovering from a cold, so Greg's taking one for the team today and doing bulk of the talking. Thanks for that, Greg. Before we jump into the California specific case study, I think it's important that we understand the recent regulatory drivers related to the management of organics in California. So if you can all see, I have what we call the SB 1383 key implementation dates timeline. In September of 2016, the state of California adopted new laws and regulations for the management of organics. Specifically SB 1383, it sets goals for the diversion of organics from landfills, which is 50% by 2020 and 75% by 2025. So for those of us living in California, we know that as of January 1st this year, SB 1383 went into effect. So for the past couple of years, and now more than ever, we're seeing private and public sector waste management entities are evaluating the need for expanding their existing facilities or just simply adding new facilities to handle the materials that are being collected and must be diverted as a result of these new mandates. And in parallel, we also see the regulatory scene developing. Greg mentioned, the regulatory side in New York and in California. And yes, we're seeing participation of the water board. We're seeing participation of the local enforcement agency. And, we've seen wide requirements on the air side. There are some jurisdictions that do not permit composting facilities. And then there are other air districts that treat the composting system like any other industrial setup and have full permitting and testing requirements. So one such entity is our client, the city of San Diego, and they have a long history of green waste and composting operations. So in addition to the underlying regulatory driver of SB 1383, because of the city's past experience, they had very clear, well-defined goals of minimizing the footprint of the composting system, minimizing odors, and also leveraging the existing infrastructure. So the city, like I mentioned, has long operated the traditional windrow composting system, which, if any of us have been involved with traditional windrow composting, we know that it can have increased processing times. The finished product depends significantly on the feedstock, and we can have challenges related to potential odor concerns, stormwater impacts, and things of that nature. So when it came time for the city's balancing act to meet the SB 1383 regs, they took a two-phased approach. They elected to divert more than 100,000 tons of food waste. And we said, okay, we're going to do it, one, by diverting food waste, by working with nonprofit food rescues so that the food gets diverted even before it hits the gates of the landfill. And the second was by upgrading to a state-of-the-art composting system. So they elected to divert as I was saying, nonprofit food rescues, as well as upgrading their composting system. And for the composting system, because of their extensive experience with windrow composting and the other pilot studies they've conducted, the city elected to move forward with what is known as a covered aerated static pile compost system, which reduces processing times. I have 8 weeks on the slide, as you can see, compared to the 3 to 6 months, provides significant improvement in odor control, and also creates enhanced stormwater management. I'm going to pass it on to Greg to share what an ASP looks like.
Okay, thanks, Vidya. So yeah, picking up off of what Vidya was just talking about, and first thanks to our friends at Sustainable Generation and Gore for this graphic. But this presents a covered aerated static pile system. Here, the focus is on the middle part of the photo, where it says step 2, step 3, step 4. So that's really phase 1, phase 2, and phase 3 of the compost process. So the dark green is phase 1, the light green is phase 2, and then the tan brown color is phase 3. So key thing with this type of system is that we can process a lot of material in a relatively small footprint of land. And so that was a key consideration for San Diego, is that they had a land restriction. So importantly for San Diego, they were doing the composting on top of their landfill, but still they wanted to keep the footprint small. So they went with this system, which again provides a lot of throughput with a small footprint. The other key thing is the odor control aspect. So the first 2 phases of this employ the Gore cover membrane system. So we have a lot of process control as well as odor control with this type of system.
Greg and Vidya, somebody asked the question with regards to how many acres is the San Diego site. You might be covering that in a bit, but that was one of the questions that was asked.
Okay, I will be covering it in the next slide.
That's coming up in the next slide or two. So yeah, so good segue. I guess we'll hand it back over.
Thank you, and thanks, Bob, for that question. So yeah, just a little bit about the City of San Diego covered aerated static pile project. The city put out an RFP for a design build project, which was awarded in January of 2018 with SCS as the prime. Greg already mentioned Sustainable Generation, who were the technology provider. And the project overall cost was about $4.49 million, with costs being offset by part of the cost being offset by a Cal Recycle grant. The project is the composting system is designed to accept mixed waste, that is food waste and green waste. And everybody just has to remember that this was all in preparation for SB 1383. And the capacity of the system was initial throughput was 40,000 tons per year, with an option to expand and add another 20,000 tons per year. Feedstock was to be prepared by the city. The ASP system, so the equivalent of the 40,000 tons per year in terms of the ASP system, is a 24 heap system with an optional adder of 12 heaps. The cover system was a fabric cover system, which was specified by the client. And a couple of other things that came into play was, along with the fabric cover system, there is a mobile winder that is, when we have some pictures to show you, that is equipment that helps place and remove the covers. So for those who are familiar with landfills, think about these as tarps for the composting heaps. The interesting thing is the RFP required a diesel mobile winder, and we were able to provide an electric winder. And as you'll see down a few slides, the benefit of it. And finally, power source. Initially, the project was to be run on a generator for 12 months and then to utility power. The city's already, their utility power, they have landfill gas to energy plants. And so they were trying to go full renewable energy and fully sustainable with this composting system. And so to answer the question that was asked, on this Google Earth image, here's the project location, and the green outline is, you can see actually right outside the green, you can see the heaps of from the windrow composting, but the green outline is about 3 acres, 3 or 4 acres, and that's what's keeping in line with the city's goal of minimizing footprint, utilizing existing infrastructure, and siting this new system with more throughput on the city's landfill. Then here's a sheet from our engineering construction plans. We were successful in eliminating the need for grading, which was also something that the city had requested. We were able to lay out the ASP so as to integrate it with the site's stormwater infrastructure, as well as the landfill gas infrastructure. So that's something anybody who's considering siting a composting system on a landfill just needs to keep in mind that, you know, there is the landfill gas collection and control system, and, you know, those monitoring requirements don't go away. So we were able to marry all these different disciplines and come up with a layout that meets all their needs.
Vidhya, one of the questions that was asked is on the, I think the $4.9 million cost that you had on that slide 12. Was that the total cost, or was that the net cost after the grant?
Oh, that was the total cost. I believe the grant was, I hope I'm not wrong, but I believe it was a $3 million grant.
Okay, so about $1.9 million in total net.
Right, and actually the project, it's there towards the end. The project actually ended up closer to 4.07. And I see that a question came in. Was it on a closed portion of a landfill? No, it was actually on an interim cover. And one of the later slides does talk about the fact that when the city comes back to fill in this area, the system will have to be relocated.
And the 40,000 ton per year capacity, is that food plus green waste, or just?
Yes.
Okay.
Food plus green waste. And I can't remember right now off the top of my head what they did prior to the ESP, but their whole concept was, with SB 1383, we're going to get an increase. We're going to get an increase in the amount of materials that come through the gates towards this composting system. So they were trying to maximize throughput, which is where the technology came into play, that the covered ASP allows us to do that, you know, use a smaller footprint and process more materials.
And what ratio are you using relative to food waste to the other materials that are in the compost?
The system was designed for a 50-50. And I do remember that we started out with, you know, 25, 75, and slowly and then we tested 50-50. But then the pandemic hit and they saw very little food waste. So, you know, 2022 has been interesting, to say the least, for the city. And somebody asked a question about, can this be sited on a closed landfill? It can absolutely be sited on a closed landfill.
Okay, I'm going to pick up some of the slides here, give Vidhya's voice a rest. In terms of slides, by the way, you know, as you see on some of these slides, we have little icons in the corners. And so, you know, that's just meant to kind of give you a prompt as to, you know, what we're kind of looking at. So on this kind of quote technology slide, so this just gives a few shots of the system. So thinking back to those puzzle pieces I presented earlier with technology. So this system is a you know, ASP, so static is in the name. So it's a static system. It is using a forced aeration system. It's positive air, so that means it's the blower box in the upper right is blowing air into the piping that you see. So this is, in this case, on grade HDPE pipe, and a little bit of a foreshadowing. You know, that's a key cost consideration, and I'll talk about that in a moment in another slide. It's also, you know, it's a covered ASP system. So again, we're using the SG Gore cover system. So we do have process control and odor control or enhanced odor control with this type of system. And it's a batch system. So that, you know, we're moving mixed materials into each zone or bay, and then moving it out after a discrete period of time. Finally, on this photo, you can see in the lower right, you know, initially we were using a generator to provide electric power.
So on the actual construction of the pad itself, Vidhya and Greg, in terms of the integration with the interim cover, was it basically you were using a kind of a gravel pad that you constructed? How was that pad constructed, and how did it kind of integrate with the interim landfill cover?
So on this one, and Bob, we've seen things changing. I just want to remind everyone that it's a rapidly evolving regulatory environment. So when we did this project, I think they already had a few feet of cover, and so they didn't have to do anything special.
Okay.
They did prepare, the site did the preparation for us, and so we didn't have to do any grading. In fact, that was one of their requirements. But we have done other projects since this one, and we've seen the the regulators ask for more information, and we've had to do permeability tests, some coring to, you know, soil tests to ensure that it meets the permeability requirements. So
you didn't need any, you didn't need in this particular site because it's on a landfill. You didn't need any concrete pad.
We didn't
to control where you might need in an area that's you might need that, I guess, in certain areas. If
yeah, well, we've done projects on other sites that are landfills where we've placed, it's the exact same thing, but the regulators asked for additional testing. So I'm just saying that just because this is how it was done here, we just have to be mindful of the fact that it's an evolving regulatory environment, and the regulators could ask for more.
Yeah, and just in the spirit of comparing and contrasting, and you'll see it in the next case study, which does have concrete. So, you know, and here on this photo with our cost icon in the upper left, so that's a cost consideration. It's actually a cost savings here. And one of the advantage of doing this project on the landfill is that, you know, it's within the landfill footprint. So any stormwater, any contact water is managed, you know, similar to what the landfill does for leachate and stormwater. And, you know, the cost savings, as you can see in the upper left-hand photo, is that there is no concrete, you know, so it is just aeration pipes on grade. And you can see the front end loader has to straddle those aeration pipes and come in and build the heap or the windrow.
So do you have to relay out the pipes after you've when you do your batch movements, or can you reuse the layout of the pipes?
Yeah, so I believe with this operation and most of these, typically there's a pulling ring on the end of the HDP pipe, and so they can pull those pipes out. Of course, you have to have enough room to do that pulling, and so you reuse that pipe, and just pulling the pipe out at the end of the process just allows them to go in and get remove all of the composted material, but then they pull that pipe back in place and they're reusing that pipe. Again, we're kind of foreshadowing a little bit. Other systems have, you know, this kind of aeration piping cast in place, so then it doesn't become kind of an obstacle, if you will, with operations. So,
in terms of the inputs for this particular facility, what kind of food waste is accepted? Any specific kinds of commercial, any liquids that come with that?
Don't know about liquids, but it is commercial and residential food waste. So whatever's in our bins, it goes straight.
Okay.
Just to continue on with this photo, the bottom photo, you know, again, with the regulatory icon here is, so here's the Gore cover being deployed, which provides, again, process control and odor control. And, you know, some of the air districts in California have required source testing of compost facilities, and there is a growing body of data, I guess I'll say, or stack testing data for all kinds of different compost facilities such as this, as well as, other compost technologies.
Vidya, in your experience on doing this for a little bit now, relative to the food waste and managing that, any other issues that you've had to deal with, and how is that managed?
Yeah, I think the key is, and it's very important to have these discussions up front with the client. With the city of San Diego, they were very, very clear that they were going to move everything that comes in on the same day. So with the food waste, that's where, you start seeing VOCs and ammonia. If it's green waste only, you're not going to have as many odor concerns. So if it's food waste, you have to move quickly. And otherwise, you will need a full-on organics intake facility. And that's not this type of a system. That's a very different system.
So just wrapping up San Diego somewhat with one last photo slide here. So, one of the things that we're able to do, and which, again, with our, one of our key factors being land, this is an example where the compost facility is on the landfill, as we've been talking about. But, we need knowledge and we need to work around things like the landfill gas system, which is shown in the upper right-hand corner of this slide. And the other thing that we need to provide for a ASP type system is, electric power to run the blowers. And so there is possibilities, and we have been involved in a project in California where we've provided that electric power through solar panels. So that's pretty neat technology that can be deployed as well. Here's a summary, just to, again, wrap up the San Diego project. Some of the cost numbers, I think we're consistent there based on a clarification that Vidya gave on the total overall cost of about 4.1 million, and the state grant of about $3 million. Here, the pros with this approach is, again, with the key factors being land and regulatory, we had a land restriction, and we met that with the compost technology that was deployed, which is able to process a lot of material in a relatively small footprint. Odor concerns were abated through this system, and stormwater impacts were minimized as well. And finally, costs were minimized by the on-grade construction, as we've just been talking about. So avoiding concrete construction if we had to do this, say, off of the landfill footprint or at some other site, that's a significant cost for these kinds of projects. One of the cons is, as Vidya alluded to, is that, being on a interim cover part of the landfill, there's possibility that the system would have to be relocated in the future due to landfill expansion. And that's among other reasons why, concrete wasn't used, that we didn't want to put all that material and cost into the project and then have to get up and move, some years later.
So on the system itself, Vidya, in terms of, you got temperature monitors, I assume, within the piles, and so you make sure that it achieves the temperature. What temperatures have been observed in this process?
I mean, the key is PFRP, which is 131 degrees Fahrenheit. But just to kind of wrap up the question you're asking and what Greg was saying, see, the key elements, if you recall from Greg's slide, you've got the heaps, which have the coverage, you've got temperature probes, oxygen probes, you've got blowers, okay? And you've got the piping. So basically it's the blowers that are pushing air. It's a positive system. So it's pushing air into the compost heap, and it's that air that goes into the compost heap, and it's basically enhancing and speeding up the process, the composting process. But the temperature probes in there are the ones that are monitoring the temperature, and you have a separate server room where all the communication, all the data goes, and you can set thresholds in there, because there are regulations that say, oh, your compost pile cannot get too hot. So that's where, you can do it by programming, where if the temperature gets above a certain set point, that system turns off. But that's how the system works. Whether you do it on concrete or on landfill, The key elements that stay are the blowers and the covers.
One last question. I know we got to jump onto the Vermont case. Is had any example of relative to, I don't know, your experience, Greg, relative to using this system for biosolids?
Yeah, no, this system and, you know, other types of systems, compost systems have been and are being used with biosolids composting. So certainly viable to use this kind of system for biosolids.
Okay.
Okay, we're going to move across the country to Vermont, and you know, in the spirit of comparing and contrasting, so Vermont is pretty much the least populated state versus California, which is the most populated state. And the other key contrast is, well, California gets all the press about their SB 1383 and organics diversion. Actually, it's in Vermont that as of close to 2 years ago now, July 1st of 2020, all food scraps in the state have to be diverted from landfill and waste energy, including residential. So it's, I guess you'd say, the most, whether you call it restrictive or most enlightened state, I guess it depends on your perspective. But Vermont is leading the way, I guess I'll say, with organics diversion. And again, in contrast with the California project here, now our balancing acts, you know, our technology and costs were weighing down on us here. Our client, in this case, is a public entity, Chittenden Solid Waste District, or the district, I'll call them. And so, you know, we'll focus mostly on the technology and cost, but, you know, land and regulatory aspects certainly a part of this story as well. Here's a shot of the entrance facility. Key thing to point out is that this facility has existed since 2010, 2011. We got involved in 2019 into 2020. And part of that was regulatory driven in that, as you can see on the sign here, they're accepting leaves, yard trimmings, and food scraps. And with the Vermont law and regulation, you know, they were expecting much more food scraps. And so they really needed to up their game in terms of their technology and modify their operation and expand it. Here's a shot of the site as it existed a couple of years ago, roughly 2019. And so this is where land does play into the equation, even though you know, the overriding concerns were technology and cost. So starting in the lower left is where the waste receipts come in, the feedstocks come in, and also this, they also have an ASP system, which I'll get into the details in a moment, but the lower left is the ASP system. And then moving to the middle of the photo is their, really at this time was their curing pad. And then finally in the upper right was their sales and blending area. So with this long linear site, it caused issues with inefficiencies and cost inefficiencies. So they had to move all this material from left to right with front end loaders. And so that was becoming a problem and causing, again, cost inefficiencies in terms of labor and equipment. But jumping into the details of this, and again, trying to compare and contrast to what we saw in San Diego. So this is, I guess you'd call it a covered ASP, but it's a different kind of cover. This is, as you can see, it's just a roof structure. It's open air. This does now have concrete bays. The 3 or 4 bays on the left-hand side are really where they do their feedstock receipt. So this is where they'll keep food waste undercover and they'll mix it, or historically they'll mix it in those bays. They have changed that up a little bit, and I'll explain that in a moment. And then they do their active phase 1 composting in the 6 bays or so to the right-hand side. So here's a view of one of those compost bays. Again, this is a so-called phase 1 system. So here, in contrast to San Diego, the phase 1 residence time is 2 weeks to 2.5 weeks versus the 4 weeks process that we just saw. Here, you can kind of sort of make out, if you have good eyes, that there's grates covering the aeration trenches that are cast in place in the floor. And there's 4 of them here, as opposed to, a typical system like in San Diego has 2 aeration pipes or trenches, but a similar blower setup on the back wall, which is similar to what San Diego has. So this is and again, ASP system covered with a roof, and it has, in this case, concrete construction and in-ground or cast-in-place trenches. Next, again, and this is a historic operation as well as the current operation, the ASP portion of it. So on the left-hand side, you can see the phase 1 ASP area, and then there's a concrete apron in the middle of the photo. And then on the right-hand side is their now open air phase 2 ASP process. And again, if you can see this clearly on your screen, there is on-grade HDPE pipe. And so the material is moved from a phase 1 bay over to a phase 2 area. And again, the residence time here is a similar 2 to 2.5 weeks. So the whole ASP process is about 4 to 5 weeks versus what we saw in San Diego. They had a little bit longer phase 1, phase 2 process of about 6 weeks total. So this is where the inefficiencies started to come in. Is so coming out of the ASP system, number one, we had a long distance where the front end loaders had to move material down to this curing patio, kind of large windrows, and so the technology just wasn't working. You can see in the lower right hand photo, there's a lot of cost spent on labor and equipment turning these large windrows throughout the year. And then finally, this is if you picture back to the overall site layout, this is the far right, the lower area, and you can see lots of water. You can almost even see that front end loader sinking into the ground. So again, a lot of process inefficiencies, which translates to cost inefficiencies with the screening, blending, and sale of material. So these are some of the things that we were brought in to address. And finally, here's a graph of the incoming food waste in tons per month over the past 10 years, roughly from 2010 on the left to 2020 on the right. And with the new regulation fully kicking in at the kind of the right-hand side of the screen, there was just had to be changes done to handle more material more efficiently. And so, one thing that we do with most every compost project when we come in is we put together a process flow diagram and a mass balance or a volume balance. So that informs us as to how much room ultimately we need. So it's not only a mass balance, but also a volume balance. So how much volume do we need at the front? How much do we need in the compost process? And how much room do we need for storage? So ultimately, we came up with some site improvements. And so, we decided in concert with the district that we would move to what we call a hybrid compost system. So keeping the phase 1 and phase 2 ASP process up front, but going with more of an active kind of traditional windrow turning operation in the middle part of the screen. And so that's what you see here on the kind of the left-hand side. So we have now a windrow pad that was graded properly and constructed properly. And then also on the right-hand side, the sales and blending area, again, with grading and civil site improvements. And of course, with that, stormwater improvements as well.
Just Greg, one of the curious questions that was asked was, before this modification, when they were doing the mixing, did they mix the snow just back into the compost for moisture?
Yeah. So that's right. And we own and operate a compost turner in New England, and so in fact, it's beneficial. We often like to turn the compost piles either during the rain event or the snow just gets turned right into the compost, and so provides moisture, which is, in most cases beneficial to the process. So just a quick snapshot of the civil site construction. Again, fairly traditional civil site construction, doing some grading work, stormwater improvements. We put down geotextile and overlaid that with 12 inches of stone for the windrow pad, and I believe it was 6 inches of stone for the sales and blending area. And then beyond the so-called compost process of technology, there's a certain amount of fixed assets, which, we saw in San Diego and we saw here as well with, say, concrete pads, aeration pipes, blowers. But, a key part of any compost facility is the mobile equipment. So here, what the district decided, and it was assisted by a state grant similar to San Diego, is they went out and purchased a windrow turner. So here's a photo of that, also showing a snow shot as well. But one of the knocks on windrow turners is that's the problem, is they just have an ability to turn, but the district has kind of developed new uses for the windrow turner. They use the windrow turner to blend the incoming feedstocks, the food waste with the yard waste and wood chips, as well as blend their finished products. So they make a blend they sell straight compost, but they also sell a garden mix and a topsoil mix where they blend compost with sand and peat.
So do they just pile them on top of each other and then run?
Yeah, they
turn?
make kind of like a sandwich, if you will, or a layer cake, I guess is a better way to describe it. And then once it's layered in there, then they run the turner through the materials. Another key equipment purchase was this, I'll call it slightly used dump truck. So this is about a 20 cubic yard dump truck that's now used to move material from the ASP down to the windrow pad, and then from the windrow pad over to the sales and blending area. And so, this is, obviously an example of materials movement. This is with a dump truck. We've also seen folks use conveyors. So that there's, those kind of considerations can be thought of, looking at the overall system process. And then finally, they also, another piece of equipment they added was this stacking conveyor, which helped out with, again, more efficient materials movement. So finally, here's a shot of the improved site. You can, again, try to remember back to that original shot. So on the lower left is the ASP area. In the middle now is our improved windrow pad and more neat and size appropriate windrows. And then finally on the right-hand side is the sales and blending area. And you can kind of make out the gray area, which is the stone. So just a whole lot better process for them. So in summary, for this project in Vermont, you can see the cost here, the total cost, and then the amount offset by the grant. And our pros really, again, we're focused on technology and cost. So the compost yield has improved. They're making a high quality compost in a shorter amount of time. And then there's lots of cost savings that they've been able to realize through the turner, saving on labor and maintenance of equipment, and including the the stacking conveyor, and I should mention the dump truck as well. Some of the cons that they're dealing with now with the windrow turner is at certain times of the year they've experienced where the windrows dry out, how to get moisture back into those windrows efficiently, and then plastic contamination and there's just that mechanical action of the turner chopping up the plastic somewhat. So they've got to deal with screening, airlift separation. So just there's ever evolving improvements that they need to make at this particular operation. So in conclusion, hopefully we just wanted to kind of show the interplay between these different factors, and so especially with compost facilities, your individual situation, your individual site specifics really will dictate the selection and development of your compost facility. So with that, Bob, I think we're open for more questions at this time.
One of the questions I came across was in dealing with the 50-50 kind of planned mixture, I guess, at City of San Diego relative to food waste and other green materials. Any issues with the airflow distribution problems and binding that you've seen, or has that been working out okay on the way it's been mixed?
So far it's been working out okay. It's all in the preparation of the feedstock. And the other thing to recognize is the way that the piping works. There is a plenum layer at the bottom of the pile. And so the idea is that the plenum is what distributes, that the pipe perforations just provide the air into the heap, and then it's distributed upwards uniformly throughout.
Greg, I think you may have gone through the listing of kind of the typical costs associated with some of that major equipment that you have there. Can you maybe review that again?
Oh yeah, actually I meant to bring that up, and I don't think I did. So the compost turner was about $500,000, I think maybe a little bit less. The dump truck was $150,000, and the stacking conveyor was about $40,000. So that was those are obviously the equipment cost components. And then I think that the total cost was pushing 1.4 million. So the rest, the balance of that money was the civil site improvements.
And would you say that in terms of the general feel of the place and the operations much improved? I got a sense that they're pretty happy with the upgrades.
Yeah, no, very much so. So I think they've doubled or more than doubled the area of their all-weather surfaces, and so they're just so much more efficient. The dump truck has helped out tremendously. You got a 20-yard truck that's moving material as opposed to a front end loader bouncing down bumpy either dirt or gravel roads with a 4 or 5 yard bucket. So even just that, but then the compost turner has cut their process time down quite a bit. I did have their stats around here somewhere. I think they went from a 5 to 7 month process to 2 to 3 months. So it's definitely shortened their process time. One of the things that, I guess indirectly I touched on with Vermont is, they do have that sales and blending area, but it's also a storage area. So, this time of year, there's not a lot of compost and topsoil being sold in Vermont. And so stuff that you make in the winter has to have a place to sit, has to have storage. Whereas contrast that with San Diego, it's, there's definitely more of a chance that San Diego still needs storage area, but they probably can move stuff out and, into various uses and sales much more readily than Vermont can.
I bet. Vidhya, how many people work at the San Diego compost operation?
A good question. And off the top of my head, I don't remember. But I can find out later on. And, the question you had for Greg, in terms of San Diego, bulk of the costs were associated with the equipment. it was minimal cost with, when I say minimal, but when compared to, because there was no earthwork or no concrete work.
Now, this might be a rabbit trail or a difficult one to answer. I think we talked about this as we were preparing, but one of the questions came up is the topic of the day, obviously, is PFAS and understanding the impact that has. And I don't know whether we have really any great answer for that at this juncture, but I'd be curious if you've had any preliminary thoughts on the subject and any having to deal with it at any of the facilities that you've worked at.
Yeah, so, certainly, I know you know this, Bob, but I hopefully most of the audience knows that, PFAS is a, societal issue, and it's an upstream issue that's coming into facilities such as compost facilities. I know state of Maine has been doing a lot of work, both sampling and lab analysis and, kind of regulatory policy. And some of the things that I've seen from Maine is, and this was specific to biosolids, was, if there was some type of industrial user as part of the, the wastewater treatment plant, which produced the biosolids, then, chances were that the PFAS was generally higher, kind of an industrial impact. But, if it was just kind of standard, municipal wastewater treatment, there was some PFAS, but not a lot. And now with, certainly more awareness and trying to get PFAS just out of the waste stream in general, the hope is that, those levels will come down throughout the system, including in compost. So there has been testing of compost, and there is some levels of PFAS in compost. But it's still an open question as what's acceptable, what's not acceptable. Again, if somebody's really interested in the topic, I know state of Maine is one that's seems to be further down the pathway with wrestling with these questions. And
I guess they've just enacted some legislation last week on the subject, so on biosolids at least.
Yeah, I know they were ready to pull the trigger on it. I can't recall if it's gone through yet or not, but it's
I think it did last week.
Yeah.
In terms of the issue of accepting compostable packaging, and both in San Diego and Vermont, how have you all dealt with that issue?
I'd have to check in with the district to see what they're doing. I know at other sites, specifically there's a couple of sites in New York State that we were looking at for one of our county clients, and one of them accepted compostable packaging and the other composter did not. So I think that's fairly common, is that the composter and the operator in this case decides whether they want to take that type of material or not. I mean, one of the problems is just recognizing whether something's compostable or not. So a bag comes in and it might be perfectly compostable, but it looks like any other bag, and so it gets pulled out at the front end through some processing needs. So that's from what I've seen, it's kind of a mixed bag, no pun intended, as to whether folks allow them, whether they get pulled out in the process before they're even allowed to compost. So there's still work to be done there.
Go ahead, Vidhya.
I was going to say that so far what I've seen is compostable packaging is not being allowed. And I think one of the big concerns that the city had was starting 2022 when SB 1383 does go into effect. I think before this, they felt that they had a lot more control. But now that this is happening at the residential level, they're eager to see what's really coming through the gates. And to answer one of the previous questions on how many people work at the San Diego facility, it's 11.
Thanks, Vidhya. Well, we are at the hour, and I want to stay on for a couple minutes and see if there are any additional questions that come in, and we'll wait for about a minute or two. But excellent presentation. And while we're waiting to see if there's any more questions, Greg, one question I had for you is, you do on occasion do some pilot work relative to various composting things. You might want to chat a little bit about some of the pilot work that you do and how that information is used to plan for the future and for communities who are considering doing either food waste or just straight compost.
Yeah, so we do have a mobile compost system. It's actually an SG Gore system, and so that is trailer mounted. We have used that in Virginia doing biosolids composting, and also in Connecticut doing food waste composting, and we're scheduled to move that equipment down to Alabama next to do food waste composting. So, it depends on the specific client, but, it gives them a chance to, literally kick the tires and, see what the process is all about and, see what the end results are, in both cases that we've worked on to date. We're able to sample and test the material as it goes through the process, so we can see how the process works and what the end result material is. And again, they get a sense of what material handling requirements are for such a facility. So it's I think it's a good system to inform the clients as to what they might be getting into if they went to buy a permanent kind of more full-scale system.
Right. Well, a very informative discussion today. Thank you, Vidhya and Greg, and I apologize for being a couple minutes late. I was tied up on another call, and thank you for heading on anyways. But again, very good. Thanks for all the folks who tuned in today. And as you know, SCS, we've been doing these webinars now for almost going almost 2 years or so. We cover a wide range of topics. So keep attuned to what we're doing, and we'll let you know if we've got other interesting topics that you might want to participate in future webinars. So again, thanks everybody for taking some time and listening in today, and have a good day.
Thanks, Bob.
Thank you, Bob. Thank you, Diane. Thanks, Greg, for being my voice today.
Bye-bye.
All right, I'll see you.